Okay. Hello, ladies and gentlemen. Thank you for joining us today. Welcome to our VIROO webinar on enhancing VR capes, multi-user VR, and rapid content sharing. As you all know, VR capes are now poised for a revolutionary transformation with the integration of VIROO. This cutting-edge technology allows for the deployment of immersive multi-user content in cave automatic virtual environments, managing hardware sessions, procedures, and incorporating specific DTrack and MultiDisplay capabilities. Our webinar today has a format that includes 10 minutes presentations for each speaker, covering key takeaways such as understanding VRK technology, real-world applications, technical innovations, future trends, and of course, an engaging Q&A session. Our speakers today would delve deep into this potent combination, unveiling how VRO elevates the immersive experience and expands possibilities within VR caves. Joining us today are industry leaders like Carolina Cruz-Neira, Sergio Barrera, Dawson, Andreas Werner, Andreas Schoebel, Schoebel, and Kris Wullaert. Together, they will provide valuable insights into the world of VR cave technology. So, without further ado, we will begin this webinar. So let me introduce you to Carolina Cruz-Neira, the Ajit Chair in Computer Science at the University of Central Florida, a pioneer in virtual reality and interactive visualization, and the creator of the VRK virtual reality system. Welcome, Carolina. Thank you for joining us today. Carolina, we can't hear you. Maybe you're muted.
Here we go. All right.
Hello.
So now
Welcome.
I am.
There you go.
Okay.
Off you
Well,
go.
here we go. So sharing my screen. So hopefully everybody can see it. I get a message that is loading. There it goes. So we can see my screen.
Yes, we do.
So I'm going to talk a little bit about, where the cave originated and the kinds of things that I'm working on today, just very briefly. So um, as a reference, I always like to talk about what were my first experiences when I saw VR. So my first VR experience was a long time ago in 1991 when I just moved from Spain to the United States. And there was an exhibit at the SIGGRAPH conference called Tomorrow's Reality. So over there was quite a lot of VR exhibits, and I still have some of the old pictures. As you can see, this is how some of the things look like. And as I tried all these systems, I really, of course, like everybody else, the first time I tried, I was like, whoa, this is really cool. This is really neat. But as I was spending 4 days at the conference, I kept coming back to the exhibit, and I then started thinking, hey, this is really neat, but for example, it's very lonely. I wear these in those days they were called helmets because they were really big. I wear this headset or helmet, and suddenly I'm in this wonderful virtual space, but I'm pretty much alone, even though there were on those days there were some network applications. They were still using avatars, so that didn't feel that I was there with people. I was there with this kind of cork, uh, you know, things that look like human puppets or something like that. The other thing too that I noticed is, of course, it was very, very cumbersome, very uncomfortable. It was on my head. It was, squishing my face and all that. It wasn't really very comfortable. Um, I couldn't get over the feeling that I was still in a real place. My body was in a real place. So I was afraid to some extent to do a lot of weird movements because I would, in the back of my mind, I was always thinking, well, people are going to wonder what am I doing if I go and whatever, reach out to this thing in the virtual space. I'm just going to look funny and people are going to make jokes about me moving around. Um, and then the other area is pretty much everything that I saw was gaming, entertainment, uh, just things to have fun. And for me, as I was thinking about it, being more of a scientist, I was thinking, hey, this is really neat that I can go around and shoot at flying dinosaurs or something like that. But at the same time, why I cannot see molecules, why I cannot go out on a space and fly through the galaxies or things of that nature. So I had a lot of conversations with a lot of the people that were exhibiting over there, and everybody was looking at me like, what are you talking about, kind of thing. And then continue with the thinking, my other question was, how do we work together in these things, not just together shoot at some gorilla that is coming my way, but actually how we can be productive in this space. So at that time, honestly, I was not thinking on going to do a PhD. I just finished my master's and I was on a very, very wonderful, very profitable position at Wall Street in New York. So I was, I had my own limo with my driver and many other things, many other good perks at that time. So I was not thinking on doing a PhD, but actually seeing this exhibit, it changed my mind. And I was like, somebody has to come and clean up all this mess and come up with some alternative, not a takeover, but an alternative, so we can actually address all these questions that I have. So within a matter of probably 2 or 3 weeks after being a SIGGRAPH 91, I quit my wonderful job in New York and I went to Chicago to do my PhD. So over there, then I worked for about 9 months or 10 months very intensively pursuing my thoughts of trying to create a virtual system that will be a shared virtual space, a place where I go with my own body, and the people with me bring their own body in their space, a place where we can work together. And then I reach out to a lot of scientists, and I sort of made some arguments to them like, hey, if you can actually get inside your scientific space, I think you can get a lot more insight and be able to maybe accelerate your process of discovery. So I was very fortunate that I was collaborating with a lot of the scientists in the National Supercomputing Center, NCSA. Um, so in Illinois. So by SIGGRAPH 92, literally a year after I saw these exhibits, then we took the cave to as a showcase into SIGGRAPH. So that's when it went public. So it was part of an exhibit called Showcase, which was trying to showcase, all the emerging technologies that will be supporting scientific research through visualization and simulation. So when we opened the exhibit, I have the tremendous privilege to work with 10 different very, very reputable scientific teams. So we have 10 applications, initial applications that went from molecular biology to oil and gas, astrophysics, medical, oceanographic sciences. So it was quite a feat. But I quit my high-paying job to get something done, and I got it done. That was basically the drive for that. So it was an immediate success. It had a huge wow factor. So you can see some pictures of 1992 people standing outside the cave in line waiting to get in there. Of course, I didn't do it alone. You can see the picture on the lower right. That's the whole team of the electronic visualization lab where I work with. So I was the lead person in the cave, but a lot of the different students and postdocs that were at the visualization lab, of course, help and contribute to make the SIGGRAPH showcase a success. But the reality of this is when I did the cave, um, you know it's not easy to use. It's a multi-machine system, um, which by default already brings a lot of software complexity because you have to synchronize multiple machines into a single integrated environment, which of course commercial software is very difficult because most of commercial software doesn't do clustering or multi-GPU. So we end up with these customized applications. And in many cases, the cave brings high recurrent maintenance costs. So, you know, on the other positive side, the industry has embraced the cave. Uh, even on the silent years of VR that nobody was hearing much on the press, there was a lot of work that was going on with the cave. And as you can see here, there is a lot of industry applications using the cave. And I think the most important part of the cave is that it changes the mindset of the field that we are not, immersion is not a synonym of headset, but it's really a synonym of what you do to create an experience on a digital space. And but to me, after doing all this and seeing all the transformation in the field, it's a little bit frustrating on where we are today, because today we're back to like 1991, where we still have the thinking that one size fits all. So headsets are the solution to everything. And as you can see on the videos, there are other very interesting. This is a shout out to Andreas, by the way. There is a lot of options out there to create this virtual experience, like the Magic Box from Lockheed Martin and NASA, our virtual table and some other things. And I think the industry today, not on this is webinar today, obviously, but outside this small community, we are really ignoring what people need to do, how they need to do it, where they need to do it, when they need to do it. And we need to provide a lot more alternatives. So for me, I had a lot of people in the last few years asking me, hey, Carolina, why don't you bring the cave technology to consumer levels? And I'm like, hey, go to the companies that manufacture the cave. But for some reason, um, I guess it's not happening. So we decided to start thinking, okay, well, what, with all the experience of 30 years of using the cave, what can we do? So we took an approach of commodity design, a good enough compromise approach, because that's realistically what the headsets are today. Reduce the complexity, being compatible to current SDKs and development environments, reduce the footprint of the system, and being very simple, kind of do-it-yourself installation and transportations, and relatively affordable. And for first time in the history of the cave, we were actually able to patent this, and we call it the VDEN. So very quickly, here are some pictures of just how we set this thing up very, very quickly. So this is how it looks like. So the reality of this system is basically is a cave, is patented, is incredibly affordable. Um, it's a quality compromise, which is equivalent to the compromise that many people are doing by using consumer headsets. The entire system is operated by a single machine, single GPU, because as you know, most of the GPUs today have 4 video out in their cards, so it's very easy to do that. So then we are compatible with all the graphics engines like Unity, Unreal, and some other ones, because they do support multi-window. They don't support multi-GPU, but they do support multi-window. Is designed to be thought about like just a big headset, so there are no need for maintenance costs of contrast or anything like that, and it's extremely portable. So it's potentially another option. It's not the only option. Again, I'm not into the only one and the biggest one and the whatever. It's just one more option that we are throwing out there. We have taken it everywhere. So we were at SIGGRAPH last summer. We have been in New York. We have been in Chicago. We have been in Houston. It's gone international at one time. You see that box over there. That's the entire system. Fits in there, But in reality, just to conclude, I really want to leave this thought on everybody's mind that really, when we talk about immersion technologies, the cave is a wonderful option, but again, it's an option. We have to have this broad thinking about VR and immersive technologies, because it's not about the system, it's about what the users need to do and what they need to experience, and ultimately just, whatever we do, it just makes people very happy to enjoy it. So with that, I'll close my presentation very quickly.
Okay, thank you, Carolina. Thank you for that valuable insight of yours, the story you came up with this type of technology and how you developed it in full. Thank you for your presentation. And now I will hand over the control to Kris Wullaert from Barco. Kris is the product and pre-sales manager at Barco with an extensive experience in pre-sales and product management. He focuses on virtual reality and simulation display solutions, driving innovation and excellence in the field. So, Kris, welcome.
Thank you, Gera. Thank you, Carolina, for your strong insights, and hello to everybody. My name is Kris, and I'm working from Barco. Okay. Going to the next slide, a bit of history on the company Barco. And by the way, for the Spanish community, Barco, it does not mean that we make ships or boats. It has another meaning. So going back to the 1930s, this company was founded as a company that was making radios. And Barco stands, in fact, for Belgian American Radio Corporation. That's because the founder bought electronic components from America and built radios based upon that in Belgium. So we are headquartered in Belgium, and that's why the name Barco has been there. So we had a history in the beginning of creating products for the consumer market, ranging from radios later onwards to television sets as well, jukeboxes, audio. But let's say end 70s, mid 1980s, we moved from a consumer market towards a professional market and started building visualization products, in the beginning projectors, for different various professional markets. In the meantime, we have been moving on with other products such as ClickShare. We are leader in digital cinema. We have displays for diagnostic imaging within the healthcare industry, and we have a lot of industry firms. But one key component that remains the same is that we visualize nowadays, especially we specialize on visualization and image processing, making sure that the best possible image can be thrown on the screen with a focus on different markets. If you look at our markets, we are centered around three core markets. The three core markets are healthcare, enterprise, and entertainment. And we are covered by a global presence. So we are worldwide active. We have sites, either production sites, R&D and manufacturing sites, all over the world. We have these sites in nearly 30 countries. And we manufacture in many different regions like Belgium, India, China, US, and so on. If you look at our divisions, so within healthcare, we have two divisions. We have in enterprise, two divisions. But we, with the immersive experience, where I'm a part of and where I'm active since 2000, so I have about 23 years experience, especially in simulation and reality type of markets. So the immersive experience is a big part of our entertainment business, next to the cinema business, where we are a worldwide leader with more than 50% market share. So if you ever visit a cinema, there's a big chance that there is a Barco projector throwing the image on the screen. Good. Looking now a little bit more into the segments of the immersive experiences, we have four main segments, that's being live events, themed entertainment. Themed entertainment, you need to think about digital art museums. It's a very big trend now to have digital art represented in various type of buildings. And to create that visualization, Barco is a player in that area. We have also corporate IX, think about experience centers or any kind of corporate environment where big visuals are needed. But today, let's focus on simulation and virtual reality, because that's where the caves are residing into. Good. What are our three value pillars? What do we want to bring to our customers? First of all, it's leading technology. So for the different markets, we want to be there with leading technology. We want to make sure that we are on top of the quality, and we design for the specific experiences that we tailor our solutions on for the different markets. Second, also very important, bringing peace of mind. What does it mean, bringing peace of mind? Well, our products are designed for long-time usage. So in certain industries, we have customers that want to use our products for 10 years, even up to 20 years. So they are there designed, and we support them also through a long time. So reliability is very important. Long-term support is very important. And also ensuring our customers the products are made for their application. And then thirdly, we want to consistently deliver the same experience by a global team of experts. So we're a company of more than 3,000 employees spread across the world with a headquarter in Belgium. Now, what do we do within this virtual reality space is that we have different technologies that we, as a manufacturer, because Barco is a manufacturer, we have different technologies that we can use to create immersive spaces. We have our projection technology, which in the meantime has become a very reliable, very proven solution. There's still a lot of technology changes in there to make them longer lasting, less maintenance, easier to use, a lot of software capabilities to embed them easier in a customer application, and also allowing to do diagnostics and so on. Next to that, we also have LED and LCD video wall technology. We create and we manufacture and design our own reprojection screens, mounts, structures, mechanical support structures. And we also have a set of image processing technology, which ensures that we can bring the image from the source, being the computer, the graphics PC, towards the display in the most optimum way, not losing any quality in between. Now, let's focus a bit more on what we call group VR solutions. So, as Carolina mentioned, there are more ways than VR headsets to do group VR experiences, especially. With Barco, we have been starting our division, I think, focusing on this area about mid-90s. That was driven mostly at that time due to the automotive market going to digital prototyping. But then we started on working on collaborative VR solutions where you can go with a group of people into a VR environment to either make decisions or to get insights in certain 3D data. And we have created a portfolio of different products where the immersive feeling can change. So our first category is what we call the power wall. It's a single big seamless screen where you can create an image. These screens can go up to 10 meter wide, 3 meter high, even 4 meter high. But they are single large screens where you can show a VR environment. The next step that creates more immersion is what we call our canvas solution, where we combine 3 screens under 45-degree angle to create a more immersive feeling. Now, by filling more of your field of view, you create more immersion. It's not a 360-degree environment yet, but still you get more immersion. Besides that, the canvas is what we call a versatile solution. It has been designed to fit in a standard meeting room environment. And with the needed image processing, we can turn it from a standard meeting room environment where you can put various sources on the screen, like teleconferencing data, 2D data, but you can turn it around with a click on a button into a 3D VR environment, where with multiple people, you can be tracked in a VR environment and engage into the details or into the 3D data that you want to either study or where you want to make decisions with multiple people. Being in that environment, you typically wear what we call the 3D glasses, the similar glasses that you would wear in a 3D cinema. And that allows also still to see the other people, to have a real human interaction with other people in this environment. The next step is then what is called the cave. That was represented by Carolina as a concept. It's typically, in a lot of cases, a cubicle environment where you step into, where you create more immersion by adding more screens. You can even go to a full 360-degree immersive environment. The last category, what is mentioned here is to show that we as Barco, we have a couple of standard solutions, but in a lot of cases, we work with customization because our customers come to us and say, we have this kind of building. What can fit in there? Can you optimize your solution to fit in there, to fit our needs? We need more resolution. We need more pixels to see. We need more detail. And so we custom tailor them to their wishes. So any custom solution, which is a VR immersive environment, can be designed by Barco. Okay, just a little bit slide of different categories of cave solutions that we typically see in our market. Is ranging from a three-sided cave where you have either a front screen, a side screen, and a floor screen, or it could also be three vertical screens, front, left, right. In the middle, you see what is most common. It's what we call the four-sided cave, which typically has three vertical walls, one in front of you, left, right, and the floor that is projected upon. So that's probably the most common one. I think we have now, in the meantime, more than 100 caves installed over the world. That would be the version that we see the most. But you can go a step further and go to five-sided caves by adding a ceiling, or you even can go to a six-sided cave where you also have a backside that can open then, of course, if you need to enter the cave, or that can be closed to be fully immersed. So this is typically what we see the most. Now, we have within Barco a very specific team. So we are a manufacturer, so we create these base components, but with the Barco XI team, we put these components together to a proven solution. And that's starting from the pre-sales, where we have a pre-sales solution design team that helps to think with the customer and the partner to select really the right technology, to select the right dimensions, to fit the user purpose. So we guide already from the pre-sales our customers and our partners in there. We have our own R&D systems solutions team. We have our own mechanical engineering team. We have also a team that does technology and system validation to ensure that if we want to bring something new to the market, if we need to push the boundaries of our technology, that it is validated up front before we put it at the customer side. We do a lot of custom manufacturing because probably if I say we have a number of standard solutions, I think our custom solutions are about 80% of what we do. So we have a lot of custom manufacturing, and we have an installation team that can help us, our partners, to deploy. So important to know, Barco is working with a partner network all over the world to install these solutions. We are focusing on very much on the image processing and the visualization hardware, and our partners will complement it with the necessary other technology. It could be the tracking technology, it could be the PCs, the cluster, it could be the software, or whatever integration into your building. So our partner network will help us to get a full solution to the end user, and we will help our partner to deploy the solutions. Good. Then we bring a number of extra services, of course, to bring you peace of mind. We have this kind of categorized in three pillars. There's the enablement, which means we will help our partners and our customers to define the right solution, to get it right, implemented on site, on time, in full. So we have also project management and so on. But secondly, the protect one is to protect your investment, because it's good to have it there, but you want to keep it for many years. You want to make sure that there is a service contract related to it, that you have access to a hotline, that you get on-site support. So we are across the globe. We can deliver that support, and we have the right packages to help you have your return on investment for many years. A third pillar, which is a quite new pillar, is the optimized part, where we are working on new services to get you peace of mind over a longer term. There's a lot of technology equipment. You want to also kind of be predictable on the longer term. Will my product maybe fail within the next 2 months? So we are working really on having our products more and more embedded with IoT to make sure that even remotely you can master the equipment, you can see if something would go wrong in the future and so on. So this is in development. We already have some parts available, but we are working on expanding these services as well. I want to end with a couple of examples of universities we have deployed in different areas. Quite some universities invest in this technology. You have an example here in Poland, where we have delivered a solution for the Gdansk University. The picture in China is from the commercial aircraft company there, who have invested in a large glass cave solution. So these screens are almost glass screens. We have the RWTH Aachen University, who has a very big 5 by 5 meter cave solution. You have also the UK Leeds University, which is in fact a pedestrian simulator. So they will do research on pedestrians and how pedestrian behavior in traffic or other environments can do. Next slide shows some other areas. In Belgium, we have an application for architectural and construction business, where we have also deployed a cave. In China, we have the Shenzhen Southern University of Science and Technology. We have a very nice installation in Canada. You will hear more about this later from Ed in Windsor, Essex. The University of Nebraska, I think it's a medical university, has a cave, a Barco cave installed. And then a couple of very recent ones, Oxford University, Oxford Brookes University. In Germany, the Fachhochschule Südwestfalen, also a university. In Obra, Switzerland, very specific use case, real estate, visualization of real estate. The use case is that people really can go into the virtual building or the virtual like this one is somewhere in Switzerland. So inside the virtual architectural building, can already make changes on what kind of floor, what kind of furniture he wants, and really can make decisions in a virtual environment before starting to build the architectural space. And the Australian one, the Deakin University, is a nice example of one of these custom solutions. It's a kind of reconfigurable cave where they can open up certain wings of the solution, make it kind of a larger front wall with a smaller side wall, or close it to make it a cave environment. So these are a couple of examples of what we have done. And these are some names of famous customers, famous brands where our technology is installed. So thank you for your attention. I give back control to the next one. Thank you.
Thank you. Thank you, Kris, for the amazing presentation of the case and what you do at Barco. Now is the turn of Sergio Barrera, CTO and co-founder of VirtuWare, who brings nearly 2 decades of experience in real-time computer graphics. He is the creator of VIROO, a VR as a service platform that makes VR accessible to companies of all sizes and industries. So welcome, Sergio, to this presentation.
Okay, good afternoon, everybody. Thanks for coming and for being attending this event. First, I would like to continue talking about some arguments that Carolina and Kris has already been talking about. Everybody who enters a cave gets amazed. Even people, young people that are very used to use headsets gets amazed, and that's because the immersion that you get when you enter a cave is fantastic. It's like another it's a completely living, let's say, sensation. So it's fantastic. I began in this field, working in this field, in the field of caves, a lot time ago. Like in 2002, I was managing a team to create a domestic computer-based cave using a cluster, using the first NVIDIA graphics cards that we were used to use in those times, and it wasn't as good as the thing that we can do now, but basically it's the same concept. And not so many time ago, I knew some of our customers, like the ones from IWA in Canada, at Dawson, which is going to present later on, which were needing to have a software like the one we were creating in the VIROO platform, but which was meant to be displayed, meant to be used in headsets. And we were beginning, we began to think about how to adapt it to the cave systems and to try to join those different paths that the virtual reality was going on, which was one in the headset sector and another one in the let's say more professional setups like caves and power walls and so on. So we decided to get this opportunity to create something new to integrate into the game. So first of all, I would like to introduce VIROO for those who don't know nothing about that. VIROO is just a software. We are a company, a software company. So we are just trying to create a standardized way, a unified way to enjoy VR. And to allow to create to our customers to create contents and do not have to worry about the complexity of those systems. You have been in previous presentations, the high complexity that these systems have. So our customers only have to worry about their content, what they want to create, not how they are going to deploy them. So in this with this in mind, we create our VIROO Studio, which is a set of tools for Unity, which are integrated in a higher complex tool, which is the VIROO platform itself. But VIROO Studio allows our customers to create very complex scenarios in terms of interaction, in terms of user experience, in terms of multi-user real-time networking, but they can do it using a set of already made components that we provide that can be extended. The functionality can be extended and can be programmed by yourself if you are able to. And this allows them to produce those immersive contents, those VIROO scenes, VIROO compliant scenes, which are going to be compatible with the whole set of devices in the market, not only headsets, but also caves and systems like that. So a typical workflow from some of our customers in the industrial sectors, they only have to worry about how to get contents into Unity, which can be done using several plugins like PXYZ or whatever. Here I have set an example. Then they can modify, adapt, and publish that contents using our plugins inside Unity, which are the VIROO Studio. And with our cloud tools, they can deploy those contents in the cloud and create a collaborative session, very, very simple. So the whole process can be shown in this image. It's like I need to create some content. I use VIROO Studio. Then I have a portal which allows me to manage that content, to manage the users I want to get that content and stuff like that. And then we have a set of players, which are the single player for desktop, the single player for VR headsets. We have our room player, which is the thing we start with, which is a multi-user free roam system, which allows a set of users to enjoy a collaborative experience in the same location. in charge of coordinating and coordination of the users and safety and so on. And we have already created the cave player, which is the same concept, but using those kind of hardware like clustered computer systems and stuff like that. The cave player, its main benefits are it allows to manage the cluster, it allows to automate the cluster, because as Carolina has already explained, cave is a very complex system, and you have to launch a lot of runtimes in several computers and stuff like that. And that can be simplified using our VIROO platform, because with just one click, you can launch the whole set of computers working in the same scene with run perspectives and so on. It's also in charge of managing the tracking system and the stereo rendering itself, which is a quite complex thing to do. And in the middle, we have VIROO Cloud, which is in charge of in charge of hosting the sessions, hosting the networking, in charge of the data storage for those scenes that you create, and in charge of the identity management of the users you want to connect from your organization, because you have like a portal in which you can set permissions and so on. This is the same in the video, just to explain it briefly. To summarize,
VIROO is the all-in-one VR platform that simplifies the adoption of virtual reality, giving companies, organizations, and institutions the
sorry for that.
capability to create, manage, and deploy VR content. Built with faster teamwork in mind, VIROO is ready for remote and in-person collaborative environments, so teams can work smarter, faster, and more in sync than ever before. Start creating or joining existing virtual multi-user sessions with VIROO's single player, enabling everyone to choose their favorite configuration to interact using a VR headset or just your mouse and keyboard from a PC. Create your VR content once and let VIROO seamlessly scale it according to your needs on multiple devices, including large-scale free roam VR rooms, while you run virtual multi-user sessions as intuitively as if people were in the same place. VIROO is changing the way teams communicate, learn, and work forever. Start scaling your innovative project in hybrid environments, fluidly uniting the best of digital and physical spaces. Think big, start small, scale fast.
Okay, sorry for that clicky noise, because I don't know why we have some static noise. Okay, so VIROO allow to connect and collaborate from anywhere, anytime. You can have a session be hosted in Spain and connect from the United States, connect from the United Kingdom, and so on. And a thing that is very important, which is that not everybody needs to be in the same device. One can connect from an HMD, another one can be in a cave, or the other set of people can be in a free roam, VIROO room, and so on. These are ones of the samples that we have created for some of our customers. And now, as we are in the cave issue, we are going to try to explain briefly how this is achieved, how the cave integration is achieved in the VIROO platform. Here we can see another video. Okay, it's a very small video, but it's very descriptive. In that video, we can see a user in the headset. We can see another user, which is me particularly, in the cave, and we are experiencing the same experience using avatars, sharing events between us, and sharing the things that we are doing. We can collaborate in any process. Okay, so how this setup is done in a cave? We have created a tool which is named VIROO Cave Player, which is another player in the set of players that we provide, which allows to set up a physical layout of displays, which is a quite complex work to do. It allows also to set up to make the configuration of the tracking system. It allows to automate the cluster, and everything is done using the VRLogic Room Player, which is a unified UX, very similar to the one that we already have in other applications our customers are used to use. So a set of displays in a cave can be represented in our software as several equipment. In this case, we have several screens which have several parameters set up. In this case, the first one is set up as the lead of the tracking system. We provided several tracking systems, so we can customize them using commands and so on. And this generates some configuration files automatically, depending on the physical layout of the cave, its correspondence with the rendering surfaces, the locations, the rotations that Kris has been talking about. We can create not only caves, but any kind of configuration. In this video, we can see how that information coming from that file is translated into a simulator we provide to check that the perspectives of every camera are corrected properly. Here we are now moving the tracker, which is it's representing the user's location. Okay, we can turn around and we can see how the cave is going to behave when we deploy some content onto it. This is integrated in Unity, and here we are tweaking some values which are real values, in this case from one cave that we have in Canada with IWA. Okay, so this extraction allows not only cave systems, but also power walls, also 360 multi-viewport domes, or any feasible multi-viewport system, because the abstraction is very simple. It's how many screens do you want to set up and how they are set up in the wall. Here, for instance, I have created an example just for the webinar on how an helicopter simulation layout could look like, which is very similar to the one that Kris has presented, but also with these two ceiling and bottom projections in the top and up and in the bottom. Regarding tracking systems, we have already integrated ART tracking ecosystem, which is being done using DTrack SDK, which is available provided by ART themselves. It provides a very high accuracy and very high reliability. It's a perfect abstraction for us because we only have to worry about working with that SDK, but every device is already compatible. So we only need to worry about how to get the track working. And once the track is working, we can use any of their trackers. And we have recently included also the HTC Vive proper trackers and base stations, because we have some customers which already have some installations using these, let's say, more domestic hardware, but it's also possible to create tracking systems using systems like this. Regarding the active stereo, there has been a historic problem with the transformation of render buffers between passive stereo rendering and active stereo rendering, depending on the platform. And to avoid that, we have created our own application, which is in charge of making the ingestion of those frame buffers coming from any graphics API, like the DirectX, OpenGL, or any other, like Balkan or something. And we convert them into industry standards, which in this case is the OpenGL quad buffer stereo application, which is just a way to convert the incoming information, which normally are separated channels for the left image and the right image. We get them into the GPU memory, which is very, very fast, and then we have created an application which is capable of sharing that context and convert them into another display layer, which is presented in other application. So we can represent it in Barco projectors using any kind of 3D glasses, like active glasses, like the morphonic ones, or wherever. And this is the whole set of layers we are working with. We work very close to Unity, where we are rendering direct text. Then we have here the shared GPU memory, which can be in an NVIDIA graphics card or on a Radeon graphics card. And then we convert that to another application, which is running in OpenGL. And that complexity is transparent for our customers. They do not need to know even that they exist. So it's as simple as making some clicks in our control panels. And that's all for me.
Okay, thank you. Thank you, Sergio, for that approach of VIROO and how it supports VRCave too. Now is the turn of Dawson, which is the senior manager and Invest with SergioX, leads the simulation team and is responsible for creating Canada's largest publicly accessible VRCave. His work focuses on testing connected and autonomous vehicle technologies that are supported by the Ontario Vehicle Innovation Network program. So welcome, Ed. Welcome today to this webinar.
Thank you very much, Ira. I appreciate it. It's great to be here today. So I'm just going to start here. Let me just start by giving everyone a little bit of an introduction of our organization and how we came to be. So I work for Invest Windsor Essex, which is a regional economic development agency in Windsor, Ontario, Canada. We are actually directly across from Detroit, Michigan. We are fondly known for a long time as the automotive capital of Canada. And like many economic development organizations, we focus on attracting new companies to the region, supporting our new companies, helping small, medium businesses to start up and grow, and really looking at what we can do in our region to help it grow in our economy. So what we did actually, we have a new department that we created, and that's the department that I work with. It's actually called Automobility and Innovation. And we have a center, and we're very proud of it. We actually receive specialized government funding from both the province of Ontario, Canada, and the federal government of Canada. And one of the programs that has been very pivotal for us is actually what started off as the Autonomous Vehicle Innovation Network. And this program allowed us to really embark on a new mission to provide specialized hardware and software to companies that are working in the upcoming automotive space, the connected, autonomous, electrified vehicle space. And when we looked at it as a network, we at the time were looking at simulation as a key pivotal opportunity to provide companies with specialized equipment they wouldn't be able to afford. And the whole concept of the VRCave was born at that time. And so I'm looking forward to diving into that, to letting you know a little bit more and some of the things that we offer here. Next thing, so at the Automobility and Innovation Center, people ask, what is automobility? So I'll start there. We've defined it as the secure zero emission movement of people, goods, and services using advanced information technologies. So for us as a region, we had put the flag in the ground that we are transitioning to be known as the Automobility Capital of Canada. And how we're going to do this and how we have been doing this is to work with our regional ecosystem, including our post-secondary programs, through our local government, both the City of Windsor and County of Essex, and through our national and binational partners, both within Canada and globally, to really support entrepreneurship and innovation in this emerging automotive technology sector and the next generation of vehicles. So, oh, let me go back here. So with that, we were proud to first unveil our VR cave on May 29th, 2019. And we are happy to say it's recognized as Canada's largest publicly accessible VR cave in Canada. And just to give a lot of shout outs to our esteemed guests today, Barco and ART. So we deploy a very customized environment. In fact, everything was done for the space that we have. We have a very, very large area that was originally designed to accommodate a large transport truck. And in the space is so big that we were able to create the cave with 4 by 15-foot screens from Barco. It has one of the latest Barco UDX 4K projectors. We have the active stereoscopy and ART Track 5 motion capture system. We have 6 cameras in all, allowing full body tracking and finger tracking. And it really is such an amazing immersive experience. When we originally designed it, it was with the mind of simulation. And when we were looking at how do we help when we test eventual level 5 autonomous vehicles. And the partnership came up at the time with ANSYS, which is advanced simulation software. And as we started embarking down that pathway, we've done very well. We have digital test tracks that we deploy, including the first ever Windsor-Detroit tunnel, which is an international border crossing down to 3 millimeters of accuracy. But one of the common messages that we received was from anyone who came to see a demonstration was that this would be great for walkthroughs. This would be great for design iteration. This would be great for training. And so as we started looking at, we were coming to the end of our first bit of funding through the Autonomous Vehicle Innovation Network, we put together an application under what is now called the Ontario Vehicle Innovation Network. And we worked with our partners at VirtualWare to say, how can we integrate the VR cave, which is our prized possession for hardware and software, and how do we make that part of your ecosystem to allow the virtual walkthroughs, to allow the training, to allow multiplayer, multi-system configuration. And in the wizards that they are, Sergio and the team were able to create this multi-user real-time collaboration opportunity for us with the custom VR cave player, which is now available to everyone to utilize if you have a VR cave, which is remarkable. So I'm going to go into a little bit of detail with that, but just to finish off with the capabilities here, we have technical staff here that can assist with simulation, with software development and digital twinning, and we even have an automotive cybersecurity professional. So we work with SMEs and startups working on the next generation of vehicles and technology, and we provide them all these services free. So when you see in this slide here, we just leave it on its own. We are able to provide complimentary access to our VR cave and all the tools that we have, thanks to the funding that we received from the province of Ontario through the Ontario Vehicle Innovation Network and all the 13 programs that we run. So we are happy. We've engaged with many companies, both startups, medium size. We've even spoken to large clients, but our sweet spot is to help the companies that can't afford to have these solutions and take them to that next level. And so with the VIROO platform, we are able to provide free licenses, and these licenses can then work either at the VR cave using the headset, using the room that Sergio was talking about, or using a desktop computer. And so we now are able to work with these companies and provide them complimentary access thanks to Oven and our participation as a regional technology development site. So this is a wonderful opportunity, and our hope is that once we give them access, then they will see the benefit of the VIROO platform and go ahead and continue to utilize it well past our interaction and engagement with them. So I wanted to say, from a content creation standpoint, the team at VirtualWare has made it extremely easy for us to import, our content into the VR Cave player. Everything for the full mosaic setup, which I know has been talked about by Sergio. It's been so easy to do. For example, we take an FBX mesh and we can have it working within the cave and the other supported platforms within our system within minutes. And so when you look at these images and examples, this is just directly from the software. Our software developer, Brian, he just took one project and he was able to just put it in and deploy it within minutes. And we think that this is remarkable for us moving forward and a lot easier than when we first launched our VR Cave and how we did things with the previous software that we used. This right here, you can see the image on the left is Brian. He's moving around. We have a workstation, which is where we have a standalone VR headset. And we were luckily through VirtualWare, we now have a Vive XR Elite headset, which we are working with and testing. It's remarkable. And the image on the right is the cave, and you can see the avatar in the background where Akash, our mechanical engineer, is interacting, and Brian is using the Vive XR headset to collaborate together. So whether you're at our center, which is, we can utilize many headsets in the cave and computers simultaneously, or whether you are across the globe or within here in Canada, we can work together thanks to the VirtualWare platform. So one of the projects I just wanted to quickly highlight is something that we're very proud of. And it's a project that we worked with on behalf of a trade organization in Canada called APMA, which is the Automotive Parts Manufacturers Association. They had a call to action to create a 100% Canadian zero emission concept vehicle. And it was dubbed and named as Project Aero. It paid homage to a famous program that was scrapped many years ago in the 1950s called the Avro Aero Interceptor aircraft. And that's why you see the airplane behind the vehicle itself. So what we did, our team got together and we were able to go ahead and create the high fidelity model to deploy in the VR Cave. But now using the VIROO platform, we can deploy this much easier using the multiplayers. We can do this in the cave, on the XR headsets, on the VR headsets, or anywhere that we go. And we're going to be making it more AR friendly so that you can actually take the components from each of the different companies that have contributed and celebrate their contributions to this vehicle. And so we are very excited about that. But these images you can see, we went from the virtual prototype to actually bringing the vehicle. And here's the physical prototype right next to our large scale cave. So it was a very proud moment for us and for Canada. So when we think about the VIROO platform moving forward, we know it's going to be absolutely critical for us in the regional ecosystem. So one thing I will add, so Windsor Essex was very fortunate in Canada to land Canada's first gigafactory battery manufacturing facility, which is a joint venture between Stellantis and LG Energy Solutions. This $5 billion investment is creating a whole new sector in our region, centered around, again, continuing on the journey of electromobility, but also around battery manufacturing. And so the region, as good as we are, we have 1,000 different manufacturers. We have such a heavy cluster of automotive and automotive technologies, but we need to showcase what the process will look like when it comes to the creation and the assembly of these new batteries, these lithium-ion battery packs. And so this image right here is just showing a student on something that we're creating. We're creating a full battery assembly line, and we're utilizing the VIROO platform to be able to showcase this both at our center and far beyond. And so we really believe that moving forward, this platform is going to be integral for training, design iteration, and something that we're very heavily involved with, digital twinning applications for our manufacturers and other sectors. And so we are honestly grateful for the work that we've been doing with VirtualWare. The team in Canada has been amazing, Michael and Anna, to work with. We've been really promoting it as much as we can. And the technical team that exists in Spain, I couldn't believe how fast they were able to get the cave working. It was honestly a little concerning for me because we have this big investment, and can we make it part of a new ecosystem so that the future looks bright, and that we can leverage the cave moving forward? And we're very much on that trajectory and excited. So this is the end of my presentation, and I just wanted to thank again all the contributors to the panel, and I'll pass it back to Yura.
Thank you for that amazing presentation and that use case of VIROO and your VR Cave in Windsor Essex. Now I will hand over the control to Andreas Werner, who is the Business Development Manager at Advanced Real-Time Tracking. He has 30 years, he's been 30 years in virtual reality and is specialized in advising customers from conception to installation and optimization of VR tracking systems in industrial applications. Andreas, welcome.
Okay, thank you for the introduction, Jera. And yes, I don't want to do much a products presentation here. Oh, no, I have to find out how to get forward and backward in this. Okay, yeah, so that's me. I'm working nearly as long in VR as Carolina in the beginning. I also started in a university group for visualization. In that group, I already did collaborative virtual reality, like it's now done with VIROO, but absolutely not on that level. It was a university code. Nevertheless, we built up the first cave in a university in Germany in '98, which was, interesting enough, the highest concentration of caves in the world at that time, because on the other side of the road, the Fraunhofer Institute had one, and 10 kilometers south, Daimler had another one. So then I worked for spin-up vicinity, and then I went to ART. So my personal focus is VR in projection systems and simulators. Okay, ART, the company is also pretty old in the VR business, so nearly 25 years now, 24 years now. Okay, we do optical tracking systems for professional applications, and yeah, we have a wide range of systems. You have already seen some of our systems with Barco and with Cave in Canada, but I wanted to show you different sizes, because this is a simulator where we have about 80 centimeters of tracking distance and a person that can't move out of his chair but needs a very precise and fast tracking for that. And on the other hand, here below, this is a cave that is 6 meters wide, 3 meters high, 3 meters deep, and the sides can flap open to create 12-meter wide pole walls. So that's about the other size of we have, and that's not even the limit. We have some interaction devices. You have already seen the upper one in more than one slide so far, and also finger trackings, where you can really see the finger positions with a high accuracy, because we are measuring directly on the fingers. And we also do some other work now, like for instance, making sure that handheld tools are only used at the screws they should fix, and are not able to fix wrong screws, or where we have to check that they are fixing all the screws. Very important for what we've just seen in the last presentation for battery production, for instance, because if there's a screw missing and you build the complete car on top of that battery pack, you don't want to fix that screw afterwards again. So also object identification and so on. Okay, so let's stay in the basics. Why do we do VR at all? In fact, we want to fake something. We want to do as if we were in the real world. And so we have to fool the human perception system, because we are not in the world that we want to show. Okay, what do we have as a human? We have 2 eyes, and the eye is a great sensor. It has 120 million sensors for luminosity, so for black and white sensors. Not that much color sensors. We have pre-processing behind that by specialized cells that find the connectivity between in elements in the picture, and then a great neuronal network in our brain. We also have a little vestibular system that is more or less like an inertial sensor. And all these informations are automatically combined by our sensors. That's trained in the early life. Everybody who had a child has seen how it started training that to do balancing. And if we do that wrong, then we experience things like motion sickness, which is the main problem with virtual reality, and which is mainly a problem of not doing things exactly correct, because our sensing system is so good that it notices that something is not correct. And then, yes, it doesn't feel well, because the reality that it feels and the reality that is seen and the virtual reality that it's seeing is not fitting together. Okay, now we all know VR caves, we know stereo images. So how does a human see distances? And everybody, when talking about three-dimensional view, thinks about stereo vision, but that is not everything. We have other things. We see, for instance, one object covering another object, so we automatically know the other object, the blue object, is behind, so it must be further away. We see two objects where we know it's the sizes, and we see one smaller, so we know it's further back. We have the motion parallaxes. Motion parallaxes is, you know that when you're sitting in a train, everything that's close to you passes fast, everything that's far away seems to pass slower. So that's the motion parallaxes. All that is automatically combined by the human brain to a three-dimensional information. The last point here, accommodation, that only works on very short objects where you notice that your eye has to focus differently. That is not really important for the VR. Okay, now comes my part of the work, because I'm in a tracking system company. What do we track in VR? We have a screen somewhere. We have an object, a virtual object or a real object in the scene. Okay, so the first thing we do is we track the viewer's head position. We have to do that because if we see that virtual or real object in a certain point, it appears on the different place on the screen when we look from another direction. So that's why we do head tracking. But we might also have real objects in our scene that we want to move around. And then we have the same problem. We see it, we see this object moving, and we have to reposition, the computer has to reposition it in the image correctly, so we see it in the correct position for us. And what happens if this is not precise? Yeah, we might have jitter. Everybody knows jitter. Every measurement has jitter. There is no measurement without jitter. And if we can see that, we immediately feel out of the reality. We simply know that the ground is not shaking. And if we have that in the scene, we get dizziness. And if objects are not staying in the correct position, but jitter around, we can't really precisely interact with it. That's more known to, let's say, dinosaurs with me, who still know the magnetic trackers, which tended to jitter in the centimeters range and tended to rotate in a few degrees jitter. And with modern tracking system, jitter is not really that much of a problem, but it is still existent. Offsets. If the measurement is not giving you the correct position, and that can be, by the way, two problems. Either the tracking system does something wrong, or the adjustment is not correct, that you haven't measured at the correct place for your zero position. If you have that, stationary objects are not really stationary. So you move around and you have the feeling like the floor is moving a little bit with you. That's usually a wrong adjustment of the tracking system. So the tracking system can't do anything. It's just not positioned at the right place. So you have to measure that correctly and adjust it correctly. If you do that, you immediately get motion sickness sooner or later. And you have a last point, that scaling, that's rarely ever a problem nowadays. That means simply your measurement is too wide or too small, then objects might move against the track. So you have an object in your hand in one place and you go to the side and it's suddenly a few centimeters right or left of your hand. That means you have a scaling problem, but that is not very often a problem. Okay, so the requirements for the tracker in VR are precision and accuracy. And by the way, that's something I like to mention. Precision and accuracy is two different things. Precise means all measurements are somewhere in close area to each other. Accurate means they are in average at the right point. We need both for the tracking system, especially for AR. If we want to overlay real objects and virtual objects, then we need that very precise and accurate. In a projection system, the accuracy is not as important as the preciseness, but anyway, for good tracking, you should have both. Jitter, of course, for projection, rotation is not that important. Position is very important. For an HMD, it's the other way around, because if you turn your head, the scene changes very strongly. So if you have a rotation jitter in an HMD, it kills everything. And that's why nowadays, every HMD has an inertial unit in it, because the inertial units have an extreme low jitter in it. And HMDs, you have to say it, there is no tracking system that can do an HMD. You always have two. You have an inertial in it and an external measurement that gives you the position in the real world, because the IMUs will drift and the opticals will jitter. And so you always merge two systems, whether it's a lighthouse or our system, you will always merge the internal system and the external system. Okay, and now we come to the last point, and that's the user. What does a VR user, so the person really in the VR, expect from a tracking system? And the answer to that is astonishing. Nothing. Because an end user doesn't want to see the system. An end user wants to run an application and doesn't care about any of the technical part in it. The end user wants to have a realistic behavior. And so the best compliment that an end customer can make to a tracking system company like us is, oh, we have a tracking system. Because that's something that's being turned on and runs in the background, let's say like the cooling pump of your car. You don't really care for that. It should just do its job in the background, be precise, do exactly the work it should do, and never be visible to the customer. And that's what we are working on. And that's, by the way, why you have so far seen all the caves only with our tracking system, because simply they want to install it once and run it forever and exactly don't want to care about it at all. Okay, and that was everything from my side. And I'm turning back to Jera.
Thank you, Andreas, for that wonderful presentation of yours. Thank you. How you show your tracking systems and how they work with VR caves. So last but not least, now is the turn of Andreas Schoebel and Christian Schoebel, who are co-founders and managing directors of VRLogic. They contribute to the field through consulting, sales, and support of VR, AR, and 3D solutions since 2002. And they are dedicated to this revolutionary training and education with this innovative solution. So welcome.
Yeah, thank you very much, Jera, for the introduction, also for the speakers before us. Yeah, Andreas will give us a short introduction about VRLogic, what we're doing, what we're focusing on. Myself is one of we founded the organization in 2002. And yeah, and we hope to give you some further information about our organization and our focus. Andreas, you can.
Yes, I will continue. Good afternoon, everyone. Thank you, VirtualWare, for inviting us to participate in this webinar. Like my brother Christian already said, we are both managing directors of and co-founders of VRLogic. Our office is in Dieburg, which is in Hessen, Germany, close to Frankfurt. Why are we speaking here? We've been in this industry for 30 years now, and yeah, we've seen quite a lot of virtual reality technology. We have seen the development of a lot of different tracking solutions, display solutions, a lot of different types of systems that create immersive experiences. And yeah, we've been a VIROO partner since summer this year. Muss ich mal schauen, I have to. We have customers in many countries all over the world, and we cover user applications in many industries with the solutions that we offer for those companies and organizations. Our product portfolio includes typical virtual reality hardware, software to create VR content, and total solutions that we customize. When we think of immersive experiences, we don't only think of an HMD or a power wall or a cave. We think further. We look at the latest innovative technologies, and these also include glasses-free displays nowadays, holographic screens, which also can create awesome immersive experiences for the users.
And nowadays, it's also becoming more and more important for the usability of this immersive solution. So not only to use it as a cave, but as a multi-purpose, let's say, solution for all parts of an organization. And last but not least, also the sustainability and the power consumption is also getting more and more important for our customers.
And in order to experience the solutions, the systems that we offer, we have a showroom in our office in Dieburg, where customers can compare diverse systems. They can bring their own data, to test with the solutions that we offer. We have all kinds of 3D displays, active stereo, passive stereo, glasses-free displays, and a 3.5 meter long 3D LED power wall equipped with AR tracking, with an AR tracking system. And the heart of our showroom is a 3-sided corner wall where we can show all kinds of content and VR applications.
And one reason where we got very excited is with VIROO. I mean, it's a very new software we're working with, and in the last 10 years, we of course have other software packages in our portfolio, but VIROO is for sure one of the software packages where the usability and especially the collaboration is working. So that's something why we have not seen yet in such a seamless possibility for the end user to really have a collaborative experience.
We are proud to say, sorry everyone, proud to say that we have installed several caves all over the world. The blue area does not show all the caves. No, we have not been that far. We're working on it. But there are several caves worldwide where VRLogic is involved in the planning and installation and servicing and supporting. Christian, maybe you can say something about those installations.
A quick summarization. The Foresight Cave at Komatsu. There is also a 2D screen involved for the main user, as you know that the standard cave solution is only one master is able to see the experience. The others have to be very clear, very near to the master user. So in that solution, the master vision was also distributed onto a 2D screen. It's used for DMU, so digital mockup, but also for after sales service support to show end users where special parts are and what some majority news in some on the system like the Radlader, English word for the
excavator, for example.
Excavator, is located for example for service and so on. On the left, there's it's a foresight cave in Accra in Ghana. It's for a GIS system for mine exploration and visualization. The lower system is the system in Barrera. It's a vocational school. They're using it for design and engineering services. And the right side, it's a university in Maribor. It's actually you cannot see it here on the image, but the cave is also flippable, so you can do it. You can open it up, and then you have a large power wall.
Now we want to show you talk a little bit more about the cave at the vocational training center in Valmiera in Latvia. This is the first four-sided cave that has ever been installed in the Baltic Seas, and we wanted to give you an impression what it looks like and how the actual cave is being set up in a short time-lapse video. So I will now start the time-lapse video, and yeah, enjoy. First, you see how the frames of the caves of the screens are being assembled. The projection screens for each side are fitted to the frame. Then the cave frame is assembled and set up. What you see next is the floor plate that is being inserted.
Floor is also very, very important and also very time consuming.
Then comes the next day, when the projectors are being installed, and in the end, the tracking cameras are being installed and calibrated.
Yeah, and we also, we have to admit that all of our solutions in the past have been made with, so we're working very closely with the IT and also with Barco, as they just offer the best suitable solutions to build such solutions in our opinion. Yeah.
Now let's move back to the back from Latvia, from Barrera back to Dieburg, Germany, last year we had a meeting. Oh no, sorry, not last year. This year in summer we had a meeting with Jesus, Iñaki, Sergio, Andreas, Werner, and this team plus our team installed. Wie geht's nicht weiter? Kann ich? Installed the VIROO software. The corner cave we have installed in our showroom is a three-sided corner. Is a three-sided cave. Each screen is 3.20 meters by 2 meters. The resolution is 1920 by 1200. The tracking is being performed by 4 AIT TrackPack E cameras, plus Flystick 2 is used for navigation. Our cluster contains 1 master and 3 clients, 1 for each side. We've installed the VIROO platform and that day, and then we initially we quickly were able to start the remote collaborative session. For this session, VIROO offers different types of players. On the left side, you see the VRLogic single player user interface, and on the right side, you see the VRLogic cave player, room player user interface. And setting up this deployment and running of the immersive content is really a very user-friendly process. Left-hand side, that's the player you use for desktop and computers and headsets, and on the right side, like the name says, it is the user interface for the cave player and the room player. So in this case, on the left-hand side, for example, you have a VRLogic user that is having a headset, and the VRLogic user has created the content. It is very easy to let others access this content, and so here in this case, you join, or you create the session. You choose your type of device, and on the right-hand side, you see how the cave user can then access the same type of session. You choose your cave configuration. You can decide how many sides of the cave that session is going to be used with, and in the next step, you are basically sorry about this. This is very sensitive, my mouse. You're basically in the session already. On the left-hand side, you see the point of view of the VRLogic single player, and on the right-hand side, you see a screen where you can select all kinds of different scenes, meaning that a session can include more than one virtual environment, can include more than one scene, meaning that the person then has started the session, can then start multiple sessions, and all the other users of this multiple session will then enter that, will then be transferred to this new scene. So this is very user friendly. The next video will now show what actually happened in our cave in VRLogic. You see multiple sessions. You see all different users. We have 5 user sessions with a cave, with a power wall, with 1 desktop user, and 2 users in Spain. So this was my last slide. Yeah. Thank you for your attention.
Thank you.
All I can say is that it is easy to deploy content across many different types of devices with VRLogic. It is very easy to start a collaborative session, and yeah, that's very important when you operate a cave. So we think VRLogic and caves are a perfect match. Thank you. So I want to hand the control over back to Jera.
Okay, thank you, Andreas and Kris and Christopher. Thank you for your presentation. So now we will open the floor to your questions. Yes, so we're here to answer anything you might have on your mind. Ask anything on the chat. You might have some queries. Otherwise, I will ask some, because I have some questions regarding the presentations too. maybe we can help that out a little bit. Yes. Okay, so for instance, from what I got from your presentation, I would like to know if it's possible to install VIROO Cave Player in a single computer equipped with a powerful graphics card with several outputs.
Okay, I think that's for me.
Yes.
Yes, we have the ability to create setup configuration files, set of files in a JSON format, which allows us to set if we want to be a cluster or we want our installation to be a single computer, and there specify which outputs of our graphics cards we would like to use. So yeah, it's possible. We already have it implemented in one of our customers in Valencia, and with modern hardware is quite useful because it lowers a lot the budget of the project.
Okay.
And the maintenance is very simple. So, and can be one solution for the product that Carolina was presenting before, because it's the same concept. Yeah. So yes, it's possible.
Okay.
Okay.
Good to know. Do we have any other questions? Okay, so we have a question. Someone is asking, how do you all maximize GPU performance with these applications in a cave setting? Can anyone answer that?
It's a quite complex question too. What we do is to try to we use Unity as our rendering platform. So we try to get out the most of the graphics card using modern rendering pipelines. We now work with using a standard rendering pipeline with very well optimized shaders, but now we are working on making it works also using the new rendering pipelines like the universal one. So the performance is going to be even better than now. And one thing that we are able to do is, as we in the cluster systems, as we have the whole control over the GPU, and the graphics card is mapped to one of the displays, we can take out the most of the computer which is running that head. So we distribute the work between the set of computers running in the cave when we have more than one.
Okay.
I don't know if somebody wants to add something, but yeah, the key is to have very performant shaders in the core. Sometimes our users used to like to use assets coming from other third parties which are not so performant, and we have some troubles, but we try to advise them on how to use it.
Okay. We also had a previous question during your presentations of Cynthia Cubero that asked what type of brand of glasses via headsets are compatible with VIROO and with VIROO Cave as well, not only regarding the platform but also the cave.
Oh no, it applies to both. In the case of the VR headsets, we support everything under the SteamVR, let's say SteamVR family. So if a device is compliant with the SteamVR, with OpenXR through SteamVR, it's going to be compatible as it by default. So for instance, we have an example in which Andreas discovered that our system was compatible with the X-Tal from VRLogic that we didn't have tried because we didn't know a unit, and it's is compatible by default because it's in the same technology ledger. So as it is using SteamVR, it's compatible. And in the case of the 3D stereoscopic glasses, we are not let's say doing nothing to make it work, because we set on top the driver, in this case from the NVIDIA, or the one which is making the stereo syncing. So any 3D glasses that is capable of doing a stereo syncing across the NVIDIA drivers is going to be compatible with our system. Crystallize, I don't know, the ones that I was showing before in the presentation. So anyone that is compatible with stereo syncing. I have tried it in my case to make my tests. As I do not have a 3D stereo projector, I use the Samsung glasses in my television. So they are also compatible with those kinds of domestic glasses.
Yes, all glasses will work. Yeah.
Okay. Great. Thank you for answering that question. Do we have any other? No. Well, I have some others from my side too. Regarding to the presentation of Kris of Barco, I'm just wondering if Barco also provides this front projection cave solutions as well.
Oh, that's a very good question, because I have been mainly showing rear projection cave setups. And maybe a short background on that. If you look at cave solutions, there are multiple variants, as we have shown. You have seen front projection, you have seen rear projection. There are a lot of front projection caves deployed through our partners that use our projectors. And they have the advantage to require less space to be integrated into a room. We have been focusing as a Barco, as a manufacturer, on creating reprojection solutions, because in a reprojection solution, on terms of image quality, in terms of contrast that you can get in a VR cave, you can get better performance, but because it's easier to master ambient light coming from the environment, being it lights in the environment, or being it just the adjacent or the opposite screen in your VR environment. So we have developed a portfolio of different reprojection screens, have developed coatings, which we call high contrast coatings, to ensure that most detail is visible. So while the reprojection caves require more space, they can be more qualitative in terms of image. The front projection caves require lesser space and have that advantage. So there's no one fits all.
Okay. Okay, very interesting. Thank you.
Jerry, all cave solutions we provided were made with Barco systems front projection. So,
okay.
Yeah.
Okay, thank you. Yeah, that's great to know. Are there any other questions from the attendees? No. Okay, just one last question from my side, if that's okay. What if regarding VIROO, what if I'm creating content with VIROO Studio tool, which is same at a virtual reality headset, and because it may be faster to iterate, or because I can't access to the cave installation, do I have to take something into account to run it in a cave later or not?
Sorry, because I was mute. No, not at all. You do not need to worry about the content. The content is completely agnostic of the device which is going to run into. So you don't worry you don't have to worry about that. Even more, one thing that is very useful is that, for instance, when you are using a fly stick from ART, that fly stick has the control buttons mapped like if it was a VR headset controller in the right hand, for instance. So you can use your headset to create actions and to test them and so on, and they are going to behave the same when you later on you use your fly stick. So not only you don't have to write it, is that you can iterate very fast, because everybody in this business can have an affordable VR headset in their office or home or something. and it's very, very quick to iterate, to generate content, to test directly in the Unity editor without having to publish that scene. And once you publish it, it's going to run seamlessly in the whole set of devices. So yes, we have already think about it.
Okay, thank you so much, Sergio, for the answer. Okay, so this was all for the day. Thank you for attending the webinar, all of you. Thank you to the speakers for being here today with us and presenting the point of view of VR caves and the use cases too. So what's next for VR caves? Thank you for joining us. Bye.
Goodbye.
Bye. Thank you.
Bye, everyone. Thank you.
Bye-bye.